This is Engineering Marvels. The classic simple machines, the lever, pulley, inclined plane, screw, wedge, and wheel and axle, may not seem like hot topics of conversation, but just as these simple mechanisms, each offering a distinct mechanical advantage, have been assimilated into the more complex machines that allow us to conduct our day-to-day business, so too have they infiltrated our figures of speech. Consider the wedge. Have you ever talked about driving a wedge between people or burying the hatchet? If so, then you've probably already got a good idea of how the wedge works. Like the inclined plane we examined previously, the wedge works by splitting a force into components. One component acts perpendicular to the inclined surface of the wedge, and one acts parallel to the wedge's surface. In the inclined plane, it was the parallel force component that offered a mechanical advantage, allowing us to push a smaller force over a longer distance rather than lifting it directly. In the wedge, it's the perpendicular force that offers an advantage. The wedge may be viewed as two inclined planes placed back to back. For example, visualize a wedge for splitting wood. Both sides are sloped and the wedge is shaped like a triangle. The wedge is struck on its flat base, and the input force from this blow is resolved into forces pushing outward along the two inclines. These perpendicular forces tend to push material away from the wedge, which is why the wedge is useful for splitting wood or as an axe blade or in other applications where material needs to be separated. The wedge may also be used for prying up heavy objects. In this application, the sharp tip of the wedge would be placed under the object to be lifted. The input force would tend to drive the wedge more firmly under the object as the perpendicular force lifts it up. It's tempting to think of the wedge as just an application of an inclined plane, but the wedge has distinct applications. Knife and scissor blades work on the same principle as thin, narrow wedges, so it's clear to see the pivotal role of wedges and related tools in the development of human society. Now that's something worth talking about. Engineering Marvels is a joint production of the Frank H. Dodderwyk College of Engineering at Texas A&M University Kingsville and South Texas Public Radio. Past episodes are available online at tamuk.edu/engineering. I'm Jason Martin.